Okay, so I mirror the screen because my presentation is a bit in a mess. Hexagram was way too interesting to work on a presentation, so it's in a state like it was 2 months ago. Okay, we're going to talk about sound chip music on the Atari ST, which is a quite old computer, which dates back to 1985, and it was born through a big mess with Commodore and Atari. So you know the old gaming console, and developers weren't happy and they created Activision, and then Atari built a home computer which had a nice sound chip called Pokey, and later Commodore built one which had a great sound chip which is called SID, which is the best sound chip ever being in a home computer. Activision then spin off some people who were still not happy with Atari, and they said, oh, let's build the perfect computer, which is called iToro. And then Jeff Miner from Atari wasn't happy there either, because Atari never credited the developers. He joined iToro, and then they asked Atari for money, and they got money, and they created Amiga Inc. And then we had the video game crash, and Atari was bad. And Commodore was bad too, and the boss of Commodore left, bought Atari, and then to fuck up Commodore, he hired the technician who developed the Commodore 64, and they created a new computer which is called the ST, and at the same time, Amiga asked for money at Commodore. And and Commodore finally paid back the money to Atari to sell, to get Amiga Inc. Meanwhile, Atari created the ST with a chip in it which is called the YM2149, which is a Yamaha chip which they built in basically for its parallel port and not for the sound. And later the Amiga came out with Paula, which is the 4-channel digital sound chip. So that's the machine we're talking about, Atari ST. 8 MHz CPU, a great CPU. No RAM, little, and so on. The chip, audio chip, which we are talking about, is very basic. This is the inside. The chip is the green one over there. It has no sprite engine, the machine has no flitter, it has no digital audio, and it has also no 3D engine. So what's this chip? It's a bad chip. It has only square waves, so the other chips could do sinus and triangle and whatever shapes you want. Here we have 3 channels, square waves. You can put an envelope on that, but you have one envelope for the 3 channels the same. Cool, a noise generator here. And this sounds like this. One moment. Okay. Usually thing happened, I lost DLC. Noise generator, yeah. Wow, I click from the front one. So, but still the ST was a great success for musicians because it has a MIDI interface. Yeah, and MIDI is musicians' dreams. And still today, there are some musicians using the Atari ST doing music because the system is so simple. The music programs have to write directly to the hardware, so you have really perfect synchronization, which you can't get with modern computers. So the Atari is still used for that. That's the specification of the chip. Yeah, what to say? Nothing. Okay. So it has 3 pulse channels, and most interesting is the envelope. It was never used as intended as an envelope, because if you accelerate the speed of the envelope, it becomes a sound, which is called in Atari musicians' terms buzz. So you have a triangle wave, and I didn't have the picture. It comes up later. And you can do sawtooth. And you can mix that with a square wave to get more interesting sounds. So what you can do like, the triangle is near a sine wave, but it's sharp. Every sound on that theory is very aggressive and for some people not nice, but some people like it, like me. So that's the envelope going through sound waves. So that's it cannot go very high in pitch, so it only does low voices, which sounds like that. So much time, there's so many slides. So for the first years this was a lot of use. So how does Atari music work? You have like a vertical blank interrupt, and that is the main play routine, which is called every 50 times per second. And in that you can change all parameters of the sound chip. And that's the reason why the envelope is never used, because if you can change 50 times per second the volume of your channel, who needs an envelope? So it's discarded and just program the chip directly. And so the envelope parameter is free for use. With all this you can do classic music effects, and some people also call the sound generating routine not 50 times but 200 times, which also gives nice effects. I'll show that later. So how was the music created? First for games, and then they got ripped from games to be put into demos, and later people like converted Commodore 64 SID tunes into Atari tunes, just by removing some special effects, so it worked. And so the Atari got quite fast a lot of Commodore 64 music basically for free, like 500 tunes were like poof, there, without much work, just a conversion routine to write. Yeah, here we got into my issue of the presentation is not finished, so we had already this slide. So where's the button to click? There should be a button to click here. Sorry. No, there it is. Le dioples muss ich geschlossen.
Die button is there to just click it without full screen. The button is there, just doesn't seem to be in full screen, so just click it there.
Wat F11 oder was?
Sorry.
Ich verstehe das nicht.
Die button ist auch so, über das Slide immer. Und das war just in Englisch, du kannst am full screen.
Ja, in Englisch, ja. So first ever demo, well, not so really, first ever demo that Atari showing cool sounds, but it's still square waves with, yeah. I have lots of problems with resolutions, sorry about that. So, converting tunes from the Commodore 64, you lose all the SID special effects. There, I think. Oh, there it is. So for everyone who knows commando from the Commodore 64, it's converted, but it sounds like shit. I skip that one. So you could use the fast processor to just blast values onto the volume registers of the sound channel. Yeah, Clubmatter. No, it's not the Clubmatter song. And we get like something like this. So the drums you hear are digital generated. The same technique was used on the Commodore 64. So you could like do better sound effects by using the 3 volume registers with a huge table to match all the different volumes together to simulate an 8-bit digital analog converter, which was done in this demo. So what is done here? It is on 3 channels, and they are basically calculating with the CPU the full sound and then output into a simulated, emulated digital analog converter. And then came the Amiga demo. Oh, yes. Which is now. This is 4 voices. So imagine the sound chip has 3 channels. Now we have 4 voice music. And the sound chip is not digital, it's 4 digital channels. So what is happening here? The full CPU power is used to calculate 4 instruments with variable speed and pitch and arpeggio and whatever into 1 digital sound channel. Then that sound channel is transferred to the sound chip via an emulated digital analog converter. As you see on the screen, nothing else happens because the full CPU is used for that. Which was a nice achievement. Yeah. So, later came huge demos which have on 1 disk like 20 minutes of 1 disk is 7020 kilobytes. The little chirp noise you hear in the background, that's the envelope misused for other things. There's somewhere a digital. Of course, I didn't find it now. So that's a sound sample on 8-bit playing through the sound chip via this simulated. And if you listen, it has a nice little hiss in it, which is very characteristic for this simulated digital analog converter. But Atari people got used to the background hiss and nice imperfections. Oh, let's see. some more digits sound in this one. There. What did I do? Yeah. Digisound. But Digisound takes a lot of space, so it's a small loop. What also came up were like heavy drums. Very good with a subwoofer. Okay, so let's talk about the envelope. Envelope can do this, and no repetition, it's unusable, that also. But this is a nice triangle, you can use that one, and then you have this one, and there's another triangle which is like, there's, sound-wise there's no difference, so basically you have this shape and that shape, that's all. And that's my demo, I just skip it. Come to the Hack Center to see it. Okay. In this demo there are some nice effects. This is the first time somebody did, instead of 50 times per second calculate the sound, did it 200 times. Don't hear it very well. Just go to the next one. This is so. This is arpeggio at 200 Hertz. And this one is also 200 Hertz note changes, which make some new sound waves you usually not hear from this chip. Okay. I just said that. So from this time on, people tried to have like other sound waves which made the normal square wave become one effect among others. And yeah, then somebody had a great idea. I just have to find the play button. And he basically emulated one of the effects of the Commodore 64 SID chip, which was pulse width modulation. And resulting, this was called the SID effect on the Atari. Not yet, that's still fiddling with envelope. sorry for cutting, we can go later on the accent and do some play around. This is still considered one of the best tunes ever on this machine, and it was the first time this effect was used. It's really a great musician. So how is it done? So you have this square wave coming from one of the 3 channels, and you have a CPU which has some interrupts to spare. So you create an interrupt to switch the volume of the channel to 0 or full all the time, but slightly delayed. So this frequency is like 440, and this is like 441. Result, you get a PWM modulation basically for free. You only have like 400 interrupts per second, which is not too much. So you can do great demo screens with a lot of effect and CPU calculation and have SID style sound. This basically changes the music scape on the Atari, this single demo.
It's like an oscillator. It's like an oscillator, it changes, it's slower.
Yeah, that's pulse width modulation, so it changes the ratio of on and off of the channel. Let's play that one. I'm not sure if this one is using the SID effect or not, but it's using digidrums. Quite better than clicks. This is again from the musician who invented the SID effect. And the Atari has 4 interrupts you can use, and it has 3 channels. So one interrupt you use for the main music routine to do the arpeggio and volume and all this, and you have 3 interrupts left, so you can put 3 times the SID effect on all channels, which uses a bit of CPU. There's even a chip music called CPU Eater, because it uses SID channels and digidrums and fancy effects. And then came this guy, and he created something new, a new sound on the Atari. That's not yet the new sound. That's just envelope with the tone after. What's going on here?
So you mean that flanger note, like
it's like flanger. So what does he do? Something was known that if you write the value for the envelope to the envelope register, the envelope starts from beginning. And if you write this value very fast, like if you have a very fast interrupt routine, you can like write it there, and then it starts new. So you get like strange shapes in your sound, which makes this trumpet style flanger thingy. Problem is, of course, the volume goes up, and before it reaches the maximum, you cut it again. So the volume is lower, but just make all the music lower, and it's fine. This is called a synced buzzer because the buzzer, which is the envelope, is synced and restarted regularly. And here comes CPU heater. No, that's the wrong one. I have a way to. That's not the right one.
You have to click the middle button on the
I don't see the lower part on my screen. I search for my other. I did open another Audacity. Where is it? Do you see it?
I think when you open a file with Audacity and you already have it open, there's a group.
Oh, yeah.
So if you now open Audacity, it should be there in the recent. Just load Audacity.
Of course, I lost the correct window I just prepared. I have too many windows. Sorry. Okay. I'll go away. So, 3 voices separated on 3 channels. I didn't change anything. Please help me fix all this. In fact, I wanted to show the CPU heater thing. So you see the restarting of the envelope. So this is a typical curve of an envelope, and then it's restarted every 3 times. Just check that one. Basically, that's mostly how square waves look on the Atari. They are not square. That's why it sounds bizarre. It's not like, oh, that's chiptune with square sounds. If you generate it with a perfect square sound, it's not sounding like you're used to. And this is caused because Atari went and the 3 output channels of this chip, instead of going it through capacitors and then linking them together to the mono outputs, they just wired them together with a stripe. And so the output from one channel goes into the other channel, which outputs at the same time. And this 3-channel output I generated with an emulator, so you can like play 1, play 2, or play 3. So did that like that. And the emulator has still problems to really replicate some of the chiptunes. They just don't work. And I will show that on my Atari, which I have at the Hack Center. There's one tune which is not playable by an emulator.
It's not a recording.
That's not a recording, that's an emulation. I can... recording. That's called... Oh, I have to say. I prepared it. Yeah. So that's from the emulator. I'm not sure if this is gonna sound correct. No. Bad. I think I have to regenerate it. So I'll show you how to regenerate. So emulator is called SC68 for something 60. Make a WAV of I don't want to override my other WAV I have. Oops. Make a WAV. So SNDH is the original Atari executable file, repackaged so that it contains only the code for playing the music and the music data. Now, that's going to be better. No. We just listen to it. It's 40 seconds in. There should be a melody here. Easy. And now original recording. What's going on here? Which one is it now? 3. What's happening here is that plays on the 2 channels the same sound, and at some point the waves got inverted, and as 2 outputs are wired together, they cancel each other out. So if I play this now in Audacity in 3 separate channels, this sound effect is not present. Well, to find my position, which is about there. noise cancelling out. But in fact, the music author wanted to have the reverse, so the emulator got it wrong. But I'm in contact with the developers. There's already a new version out, so it's fixed. But there are issues like how do you emulate a wrongly wired chip? Like, it's horrible. And congratulations for the work for emulating such things. And still, there's still some flanging going on, which I can remove by just rewiring it on 2 channels. No flanging. Anyway, I think I still have some more funky things. This is again a new sound effect, which was created by the programmer of one of the best, or maybe the best music editor for the machine. Must be around here. I mean that one. That sounds like SID, which is called the SID effect, which uses no CPU at all. It's just a very fast envelope combined with a matching tone signal, which creates this effect. Only thing what he did is in his music program, he made it that you can automatically match the envelope speed with the note speed, so you can actually play notes, which works. Okay, let's get back to the presentation. It's getting late. Okay, some resources. Okay, on this side you find all the SNDH, it's a 60 megabyte archive, which about almost 5,000 musics, of which are like 5% good. And somebody made a big project recently. He set up an Atari which played the whole archive. So on SNDH record you can get the MP3 and other formats directly recorded from the hardware. So if you don't have an Atari, go there. Then there's scene music, where you can find from all the computers and game consoles the music, but it's you can like select which chip you want, and people are voting on it. So if you want to hear the best tunes, you can like log in on that site and vote. I want to have this in the play queue, and then it gets played. The queue is never too long, like 3 or 10. Depends. And for your phone, there's Droid Sound. There's also another one which doesn't work, so I haven't yet managed to get it ready. And I run a local radio show, which is also on a podcast on Radio Ara, which every month has one chiptune. Apparently it's not good playing chiptune on the radio because it detunes some settings. I haven't had yet complaints. If you want to see demos, not only Atari demos, but all demos, they are on Poet, with links to downloads, to videos and everything. YouTube videos are usually bad for demos, so they don't show well. On DHS you get high quality videos for Atari demos. I suppose for other platforms this also exists. Games you get here and there. And the music editor from Gwen, you can get it on this address, which is called Maximizer. Right, it has a YM for the chip in the name. For any questions which I didn't have time to cover here, that's my email address, just mail me, or I'm going now over to the Hack Center to have some chiptune fun. Any questions? Now directly?
We actually tried that. I think there was some project where they tried to emulate all kinds of all computers with VGAs.
Yeah.
Have you tried that?
There is a project to emulate a full Atari on an Xilinx, and they are far from getting it done, especially the analog part of this subject.
Okay.
If you can get it emulated correctly with an algorithm, it's difficult. There is actually a project by me. I want to set up an Atari online, where people can send their sound files to. It will play the sound files and send the WAV file back, because today there are musicians which are doing music for the Atari in the emulator. They don't have a machine, or it's in storage because it's too hassle to set it up and so on. So I will do a service. You upload your binary and you get the WAV file back to actually check if the music you composed is sounding like you suppose it should sound. Some musicians told me, this doesn't sound at all like I wanted.
So that will be AAA as Atari as a service.
Yeah. That's it's going to happen sometime next year. Don't be too rushed. Other questions? Do you want some more heavy sound? I can. I'm only like 10% here. Let's take one last one. Huh?
Yes.
I didn't take the one with 16 minutes long. Oh, I have it as waveforms. Oh, let's do it. This stylish waveform.